Okay guys, so today we are looking at section 3.2. This is part 1 of the section. And we are going to be talking about what's called imaginary numbers today. So to start, we need to understand what an imaginary unit is. So the imaginary number I is the square root of -1. Up to now, if I asked you the square root of -1, you would say it just could not be done because you've never learned about it before. But now we have a definition for it. If we have the square root of a negative number, we're going to pull an I out. If we have a complex imaginary number, it's going to be in this form, a plus bi. A and b are going to be real numbers. A in this complex number is going to be a real number, like 2, 3, 4, 5, -6, whatever, and I will be the imaginary part. So we have complex numbers, and then we can also just think of this as an imaginary number. So a plus bi, as long as b does not equal 0, is just called an imaginary number. If we have a number just like 5i, this is called a pure imaginary number. And that's because it does not have a real part to it. So what do you think? What about -4 plus 5i? Would that be a pure imaginary? Does it only have an imaginary part, or does it also have a real part? It has a real part too. So this is going to be called just an imaginary number. So pure imaginaries are going to be those that only have I in them. Okay. This did not print out so well, but let's get rid of that. So the first problem you should see is simplifying the square root of -9. I have to think of this as the square root of -1 times the square root of 9. What did I just say a minute ago the square root of -1 is? It's the imaginary unit. What is the square root of 9? So the square root of -9 is going to be 3i. Square root of -9 is 3i. Over here, simplify this. Well, I have 3. And what do you think we would call the square root of -25? 5 what? 5i. And what do you think 3 times 5i is? 15i is correct. Okay, so that's a little introduction to imaginary numbers. Anytime we have a negative under the radical, we're going to write I. Now, there's a pattern for imaginary numbers. The square root of -1 is I. I squared. Now think about this. If I were to square something that has a radical, the radical just goes away when I square something that has a radical. So what is the square root of -1? If I square it and the radical goes away, what's I squared going to be? -1. I want you to take a look at your calculator. Your calculator can actually do this for you. Look down at the very bottom right here, and you'll see I. Do you see I right here above the decimal? So push second, and then the decimal, and that's going to give you I, and now do I squared. And it might give you this, or it might just say -1. Do some of your calculators just say -1? Okay, that's good. Mine is trying to be very specific, but 0 times I is just 0. So I'm really getting the answer -1 as well. Okay? It's just that the newer calculators are trying to write this as a complex number. So we can see that's -1. Now, I to the third. I to the third is going to be I squared times I. I to the third would be I squared times I to the first. That's the same thing as I to the third. Well, what is I squared? So it's -1 times I. So what is I to the third then? Negative I. Good. Make sure you get that written in there. Negative I. Do it on your calculator. I'm going to do second decimal point to get to the I, and then I'm going to use this to raise it to the third power. Enter, and it tells me that I to the third is negative I. All right, I to the fourth. Well, I to the fourth is going to be I squared times I squared. What's I squared again? Negative 1, and then I squared again is negative 1. So what is I to the fourth? 1. Now, our goal here is, on the non-calculator part of your test, I might ask you something like I to the 101st power. That's on the non-calculator part of your test. So you have to be able to think about what I to the 101st is. It seems impossible, doesn't it? But when you look at this pattern, the pattern is always going to go I, negative 1, negative I, 1. Here's why. If I want to find I to the fifth, that's going to be I to the fourth times I to the first. What is I to the fourth? So it's 1 times I. So what's I to the fifth just turn into then? I. See how I to the fifth is just I again. I to the sixth is going to be I to the fourth times I squared. So I to the sixth is really just going to be the same thing as, what's I to the fourth again? 1 times, and then what's I squared? Negative 1. Look at the pattern. I, negative 1, negative I, 1. I, negative 1. What do you think I to the seventh is going to be? Negative I. And what do you think I to the eighth is going to be? 1. When is the next time I'm going to get 1? I to what power is going to give me 1? I to the 12th, right? So what's the pattern for getting a 1 when this number right here is what? Right, and we call that a multiple of 4. If that number is a multiple of 4, the answer is just 1. Now you should know I to the 13th. What's it going to be? I. Ace has got this down. Good job. I to the 101st now. Okay, you guys agree it's I? Yeah, because I to the 101st would be I to the 100th times I to the first. So it's just going to be I. Okay, let's not say these out loud now, and I want you to try a few of these. I want you to do I to the 44th, I to the 10th, and I to the 17th. Give me a quick little hands up when you think you have all three. Okay, you can put them back down. I just want to see how many. All right, Cayenne, what do you think I to the 44th is?
1.
Do you guys agree with 1? Did anybody check it on their calculator? Okay, some people did. Can you explain why it's 1? Yeah, 44 is a multiple of 4, so it has to be 1. Okay, I to the 10th. I to the 10th. Let's go with you, Ethan. What do you think?
Negative 1.
-1. Did anyone else get -1? Good. I can think of this as I to the 8th is 1. I to the 8th is 1. And then this is going to be I to the 9th, I to the 10th. Has to be -1. Good. I to the 17th. I to the 17th. Angela, do you know that one? I, do you guys agree with I? Yes. I to the 17th is I to the 16th times I to the 1st. That's a multiple of 4, so it's just 1 times I to the 1st, that's I. Okay, good job. Let's go to the next part here. This is super easy. We are adding these imaginary numbers, also known as complex numbers. All we do is combine the real parts and the imaginary parts. So this is the real part, this is the real part. I add those two as -1. This is the imaginary part, so it's -1 plus I. All right, I want you guys now to try number 2. Janisha, what do you think? Okay, and I went ahead and did it on the calculator to check it for you, and you are correct. The calculator can also add and subtract imaginary numbers. Okay, so we did addition, we did subtraction, and now we're going to multiply. I'm going to do this one with you. To multiply these two, I have to FOIL these. So what I mean by FOIL is I have to do the first times the first. That gives me -6. I have to do the outers. That gives me plus 9i. I have to do the inners. That gives me plus 8i. I have to do the last times the last, and that's -12i squared. Now, here's the thing. I should never have a power higher than I to the first. I should never see I to the second. I need to simplify that. Lots of I's in that sentence. What will I to the second simplify to? -1. So I'm really going to have -6 plus 17i, and this is -12 times -1. Because I squared is -1. We just need to know that so well that it's just second nature. I squared is -1. So whenever I see I squared, I replace it with -1. I'm multiplying these, and so my answer is 6 plus 17i. Okay? I want these always written in A plus BI form. I guess I should say A plus or minus BI form. Yes?
I was wondering what happened to the 12. Where did it go?
Well, this 12 and this -6 I combined and got 6 because they're like terms. This 12 became a positive because I did I squared is -1.
I just got kind of confused because it just looked like the 6 just turned negative.
12 minus 6 is 6.
Yeah, it just was like 12.
Okay. All right. Okay, guys, so let's come down here. This is going to be pretty straightforward. This is the square root of 49 with what after the square root of 49? I. So this answer is 7i. What is number 2? Yes. Okay, number 3 is a little bit tougher. I have to think of this as, I know there's an I can get rid of the negative under the radical just by putting an I in the front. That's taken care of. 45 is 9 times 5, and what is the square root of 9? So this is 3i radical 5. This is the order you want to write it in. The number, the I, and then the radical. That's just common kind of notation. Okay, you guys do number 4 and tell me what you got. Tucker, do you have it? Negative 20i. Anybody agree? That's good because he's correct. So I take an I out to get this to be a positive. I take the I out. Square root of 100 is 10, and then I have to multiply that by negative 2. So I have 10 times negative 2 is negative 20i. Okay, everybody do this one. Check your answer. Get it? Understand why? Okay. Okay, and try this one now on your own. Allie, do you have it? Anybody else get the same answer? Good, that's correct. So I took the I out, I took the negative out rather, by taking out an I. That now makes this go away. And then 75, I want to break that down into 25 times 3. I always want to try to factor these down so that one of the numbers is a perfect square. You need to know all of these perfect squares. So I'm trying to use one of these numbers as a factor of 75. The only one that would work would be 25 times 3. That's the easiest way. Okay, this would be an ACT prep kind of question. I'm not going to ask you this on a test, but I want you guys to see if you could figure this out. I'll give you about 2 minutes. Great. Anybody think they know it? Not even sure where to start? Okay. This is a complex number. This is a real part, and this is an imaginary part. This does not have an I in it, and this does. This is a complex number. This is the real part, and this is the imaginary part. So if I want to figure out what x is, I would say negative 10x has to equal 30 because those are the real parts. I would also have to say that 4i is going to have to equal negative yi because those are the imaginary parts. So what is x going to be then?
3.
And then what is y going to be? Negative 4, right. Because I want to make these equivalent. So therefore, y would have to be negative 4 for them to be equivalent. And then the question's just saying, what's x plus y? So what do you get if you add x and y? Negative 7. Okay? It's just seeing if you understand that every complex number has a real part. If these are going to be equal, the real parts have to be equivalent. The imaginary parts have to be equivalent. Okay, let's go over here now. And the one I want to do together, I think this one's easy. We don't need to do it. I want to show you number 9. On number 9, we want to just rewrite this first parenthesis. What am I going to do with the negative 2? I. Distribute it. So if I have negative 2i times negative 3, that's going to be positive 6i. What is negative 2i times positive 6i? Negative 12i squared. Am I allowed to leave an I squared, an I cubed, an I anything? No. So therefore, I'm going to have to simplify that. So I'm going to have 2 minus 5i plus 6i. What does negative 12i squared really turn into? Positive 12. And that's because I squared is negative 1. So if I squared is negative 1, remember I said we just have to know that. I squared is negative 1. So now what's my final answer going to be?
14 plus I.
Everybody understand why? Okay, on number 10. I know you guys would understand how to do this, but I just want to show you the way that I'd like you to try to do it now. I wanted you to try to force yourself to skip one step. So I want you to do negative 1 times 2 is negative 2. I'd like you to try to do these together, the outers and the inners. So these outers give us positive 5i, and the inners give us positive 6i. What is that all together? Positive 5i plus 6i all together is what? Positive what? 11i. Okay? Push yourself to do those together. And now do the last times the last. Positive 3i times negative 5i is negative 15i squared. Good. Finish it. Did you get it? 13 plus 11i, because this is really a positive 15. Okay, let me show you the worst mistake in math. People say the answer to this is 16 plus 9i squared. No, you cannot just square this and square that. This is a binomial, so what do we have to do? We have to do 4 plus 3i times 4 plus 3i. Okay? Go ahead and do this on your own and see if you can simplify it completely. How'd you do? Did you get it? 7 plus 24i. Okay, guys, so I want to stop there for a minute rather, and I want you to start on some of these things, these problems on Canvas. So go to Canvas, go to today's date. And I want you to just do just the first part of the worksheet that's posted for today under modules. So if you go to today's date right here, we're doing 3.2 part 1, and you have this worksheet right here. And on the worksheet, for now, I just want you to start on the front of this, and then we're going to come back together in about 10 minutes and we'll work on the second part. Yes, Drew?
Does day 1 and day 2 even matter this year?
No, not for today, but we just break it up like that. Okay, that's it.